PowerShell is one of the most powerful tools built into Windows. In a world of some questionable design choices, Microsoft actually gave us something really great here. Now, PowerShell is a command line shell, a scripting language, and a remote management framework, all sort of bundled into one shiny utility. Now, in this video, I want to deliver a quick practical crash course in PowerShell and introduce all of the different building blocks that you can start putting together to really understand it from a functional sense, right? Really in a way that will take you from never used it before to, okay, I get it now. Now, will this video teach you everything there is to know? Of course not, right? PowerShell is something that I think you can pick up in an afternoon, but really take years to master. And so if you want more of this content, leave a comment to let me know, right? And we can turn this into a series. I'd love to get into writing scripts or how we can use PowerShell as a full-on incident response framework and much more that we can cover. Now, just a quick note before we dive in, because anytime I see Windows brought up in the InfoSec community, a lot of folks like to come out of the woodworks and shout, why would I ever touch Windows, right? Or why do I need to use PowerShell if I only use Linux? And hey, I'm all for finding an OS that works for you, but ultimately, if you're adverse to learning about or using Windows, you're going to severely stunt your reach within the field. And that's just the reality, right? Over 90% of Fortune 1000 companies rely on Active Directory and Windows to manage their networks. Although I imagine over time that number will start dwindling down. But Windows is still by far the dominant desktop operating system in the enterprise. And so if you're working in a SOC, doing incident response or forensics, threat hunting, or even pen testing and internal audits, right? Anything adjacent, there's a good chance that you'll be operating in a Windows-heavy environment. And you're gonna need to speak enough PowerShell to get by, right? Learning PowerShell just isn't really optional anymore. But whether you're using it or not, attackers sure are, right? And why wouldn't they? PowerShell is a powerful tool with deep access to just about everything in Windows environments. And it's already there, right? There's no need to drop any extra tools. And the data speaks for itself, right? According to the latest Mandiant M-Trends report, command and scripting interpreter is the top technique used by attackers. And the most common sub-technique, well, T1059001 for PowerShell. And so hopefully I've convinced you enough. And for the sake of time, let's jump right into the fun. And so to begin, at the heart of PowerShell are what are known as cmdlets. And to understand how to read and write PowerShell is to understand what cmdlets are and how they're constructed. And fortunately, it's very simple and predictable, right? PowerShell is actually one of the easiest scripting languages that we can get our hands on. And really, we can just think of cmdlets as these core commands or functions that we can use and chain together to get things done. Now, you'll be happy to know that the syntax of cmdlets follows a very consistent verb-noun naming convention, where the verb describes the action and the noun describes the target of that action. And so this makes them very easy and intuitive once you get used to it. And so, for example, if we want to get a list of all the running processes, well, we can call get-process. Right? If we want to stop a Windows service, well, I can call stop service and provide the name of that service. If we want to change the system's date and time, well, I can run set-date. Right? If I want to get the system date and time, I can run get-date. Right? If I want to delete a file or folder from the system, well, I can call remove-item. And so it's probably already making a bit of sense here, right? And there are a number of acceptable and common verbs with PowerShell, and I'll have some references linked as well for you. But commonly we'll see things like add or clear, copy, maybe find, get, format, right? Move, open, as we can see here, remove, right? Rename, set, right? And these verbs are selected to sort of reflect clear intent, right? If you want to do something to a file or a process or a service, even a registry key, well, chances are you can use one of these verbs, right? And as we've seen, we typically pair these verbs with nouns. And the nouns represent the types of objects or files or services or users, right? And the verbs describe what we want to do with them. And so we'll commonly see nouns like process or service or item, sometimes event log, user, computer, right? Even targeting things like WMyObject or CIM instance. Now, a very quick way to start exploring what's available in our PowerShell environment is to run get command. Right? So if I just call get command here, as the name suggests, this is going to retrieve a list of all the available commands in our current session, right? Including all the different cmdlets and functions and aliases, which we'll talk about shortly. And so you can see we have a ton of information here, right? But by default, it shows the command's name and its version, as well as the source module that it comes from. Right? So this is a great way to discover what's already loaded, right? And what's available to import. Now, if there's any commandlet worth committing to memory early on, it's going to be get help, right? So if I call it get-help here. And the get help commandlet is basically PowerShell's built-in manual system, right? It gives us detailed information about how a commandlet works, right? Or what it does, or what parameters it accepts, and also what output it returns. Right? And even examples of how we can use a specific commandlet, right? And so we could just run it on its own to basically get the general help information, but the real power comes when we start using it against a commandlet that we're interested in. And so for example, let's say that I'm interested in how I can list out processes on my system. Well, I can list out the help page for the getProcess commandlet, right? And this is going to show us a summary of the getProcess commandlet, including things like its syntax and description, right? We can dig deeper by adding the full argument here. And this is going to give us a full, more detailed breakdown of the individual parameters and inputs and outputs, right? And once you understand the pattern, it's really easy to guess certain commandlets, right? If you know what you want to do, there's probably a commandlet out there for it, right? If you want to stop a process, well, we can call stop-process, right? If we want to restart a service, well, we can call restart-service, right? So it really starts to make sense once you understand the basic building blocks. And so this kind of brings us into the idea of aliases. Now in PowerShell, an alias is just a shorthand or an alternate name for a commandlet or command, right? They're basically designed as more friendly and shorter identifiers that help us type less while still executing the same logic behind the scenes. Right, and so for example, instead of typing out the entirety of get-child item if I want to list out my files, well, I can just type in GCI, right? Or even dir, like the dir command. Instead of typing, get-help, I can just call help, and they're both going to do the same thing, right? And this is especially useful if you're working interactively in the console and you want to be quick. But it's also important to recognize that aliases can sometimes make scripts harder to read if we're not familiar with what's actually being called. But fortunately, in PowerShell, we have some ways to translate these kind of things for us. To view all of the available aliases in our current environment, well, we can just run get-alias just like that, right? And now we're going to get a nice long list of all the built-in aliases. And you can see here by the arrows in terms of what commandlets they actually point to. Now, we probably won't be scrolling through this entire list to find what we're looking for, right? And that would just take forever. What's more practical is that we can run getAlias against a commandlet directly. And so this helps us find out if there's a shortcut for it, right? And list them out if there are any, right? And so for example, we can run getAlias here with the definition flag against, say, the getChildItem commandlet, right? And this is essentially just gonna point us to all the different aliases we can run, right? We can run things like dir, like I said, or GCI, or even ls, right? If you're used to a Linux terminal, we get some nice parity there, right? And because getAlias isn't a reverse lookup by default, this is why we have to specify this definition flag here. And we're going to see that all these commands work the same way, right? I can call dir, and that's going to list out my directories here. I'm in the system32 folder, so maybe that's not a good idea. But again, if I call GCI, going to do the same thing, right? Or even ls, just for proof of concept. There are a few aliases that we see very commonly, whether it be within scripts or when investigating intrusions. And it can be helpful for us to make a mental note of them in the field. Right. For example, we have commandlets like invoke web request, which can be used to send HTTP or HTTPS requests to a web page or a web service, and is commonly used by attackers to reach out and download files or tools into the environment. And so if I run the getAlias command with the definition of invoke web request, we're going to see all the different aliases that we can come across here. Right? And so we can see things like curl, right? So again, very familiar if you've ever run the curl command before. We have a nice mapping there. Or IWR, which is short for invoke web request, right? Or even again, on the Linux side, we have the alias of wget, which is essentially going to perform the same thing in PowerShell. As another example, invoke expression is a commandlet that's used to evaluate and execute a string as if it were a PowerShell command. And so because of that, we often see attackers taking advantage of this commandlet to dynamically create and run commands, oftentimes without having to write any scripts to disk. So again, if I run getAlias with the definition of invoke expression, we're going to see that that maps over nicely to IEX, right? And so if we see IEX in a script or in a command line value or in a PowerShell log, we know that most likely invoke expression was used. If we want to be super meta and find out the alias for the getAlias commandlet, well, again, we can run it directly against getAlias, and we're going to find out that, hey, we could run GAL to save us some time or some character typing there, right? We could keep going through more and more examples, but I assume you get the idea. Now we can also go in the other direction, right? If we see an unfamiliar alias in the script, we can find out what it's actually doing by running it directly against that definition, right? So I can call get-alias against something like GCI, right? And it's going to tell me that, hey, this maps over to getChildItem, right? Or what I could do is run GAL for getAlias against, IWR, and we can see that that maps over nicely to invoke web request. And so we get a very nice bidirectional mapping here, right? We can look up any possible aliases for commandlets that we're interested in, or we can go ahead and translate an alias that we come across in the field to find out what commandlet it represents. Now that we've got a grasp on commandlets and aliases, we can start exploring what really sets PowerShell apart from traditional shells like the command prompt or bash. And that's the fact that everything in PowerShell is an object. And so what does that mean? Well, in other command line environments, when we run a command, we typically get plain text as the output, right? So for example, if I just hop into a command prompt really quick and run a command like task list, well, we're sort of getting this text-based standard output, right? And it's useful to read, but it can be difficult to work with programmatically, right? Especially when we need to extract specific details or maybe feed this output into another command, right? And so we typically need to resort to cutting up the output and formatting it how we like and jumping through a number of command line hoops to really get what we need out of our data. Now, PowerShell has a much different approach here, right? When we run a commandlet in PowerShell, like get-process, for instance, PowerShell isn't just dumping raw text to the screen, right? It's actually returning a collection of objects. And each object that gets returned has its own properties, right? Like the name of the process, right? The CPU, the process ID, the start time, right? And also methods that we can apply to each object, like the kill method, for instance, for killing a process. And so to prove this, what I can do is just run the get-process commandlet and pipe that using the pipe character here over to get-member. And this is one of the most important commandlets to learn when we're working with PowerShell. The getMember commandlet is basically going to inspect the objects that are being passed into it or returned from our initial command, right? This getProcess command, and list out all of their different properties and methods, right? And so in this case, it's listing out the processes on our system. We can see different properties returned like various handles, right? Or exit codes or process IDs, right? If we scroll to the top, we can start to see different methods, right? So again, we can run like the kill method to kill a process, right? We can run the start method to start a process, right? And we get a ton more information when we start working with the getMember commandlet. And so by combining commands with the pipeline operator, we can start doing some really powerful things. Right, the pipeline basically takes the output objects from one commandlet and passes them in directly as input to the next commandlet, allowing us to build more complex commands just from some simple building blocks. Right? For example, maybe we want to list out all the services that start automatically with the system. Well, in that case, I could run a pipeline just like this. Now, this is quite an involved command, right? And there are a few different moving parts here that we can break down. But basically, it gets all the services and filters only for those where the start type property equals automatic. And each service is going to be returned as a rich PowerShell object and have different properties like its display name or status, and among many other properties, its start type. Right, and the pipeline operator here is basically going to take all of the output from the left-hand side of the command, right? In this case, all of the objects that come from getService, and pass each object one at a time into the rest of the command over here on the right. And so we can break down the right-hand side here where we have the whereObject commandlet. And this is a filtering commandlet, right? It basically takes in objects and evaluates each one of those against a condition. And specifically, we have these curly braces here for a script block, right? So we could think of this as just a chunk of PowerShell code. And PowerShell is going to run this block of code for each object that gets passed in from the pipeline. And so if getService returns 100 services, well, this block will be run 100 times, right? Once per process. Specifically, we can see this green, or if I highlight this pink kind of variable here. This $_ is actually a special variable that refers to the current object being evaluated. In this case, one service at a time, right? So if the pipeline is feeding in the task scheduler service, well, then this $_ will be that task scheduler service, right? If it's feeding in the print spooler service, well, that's what it will refer to, right? And specifically, we're calling the start type property from the specific service itself, right? And now we're just setting that to equals, right? So this simple comparison operator meaning equals, right? So the condition is saying, does the current service's start type equal automatic? And so putting the full pipeline together, we're basically asking PowerShell to get all of the services, right? And for each one, check if its start type is exactly set to automatic. And if it is, include it in the output. And if it's not, then just skip it, right? And so even with these basic examples here, you can sort of see how PowerShell lets us work with rich structured data in a way that's just far more flexible than traditional text-based shells, right? And we'll take a look at some other ways in which that manifests in a moment. And so to summarize, again, PowerShell commands output as objects, not as text. We can explore these objects' properties by, passing in a commandlet into the get member commandlet, just like that, right? And specifically, the pipeline here, it lets us chain commandlets together and basically pass objects from one into another. And also, filtering objects is quite intuitive using where object, right? Or alternatively, a very short alias for where object is just a question mark, right? And that's probably my favorite alias in PowerShell. But we can use that with the $_ variable here, which again represents the current object at that stage in the pipeline. And we can execute specific actions within inside of a script block just like that. Now that we understand how PowerShell outputs objects and how we can filter different properties with the where object commandlet, let's look at some more important commandlets that help us shape our output. We'll start off with select object, which lets us choose which properties of an object that we want to keep or display in our output. And this is useful when we want to simplify our output, right? Or maybe only pull and extract various fields or properties. And so for example, if I were to just call the get process commandlet on its own, we can see that a number of columns, or more accurately properties, are going to be returned with each process. Right, for example, we have handles here, so the number of object handles that the process has open. We have things like non-paged memory in kilobytes or paged memory. We have working set here, which is basically the active memory in use, or things like the CPU here, or the total processor time used by the process. Or of course, we have the process ID, right, or the session ID. And of course, the process name over here on the right, the name of the process executable. And each one of these columns here represents a property of each process object. Now, say we only want to list out each process's name and process ID. Well, in that case, we can pipe the output of getProcess into select object. And by the way, the alias for select object is just the keyword of select, but I'm going to keep things more verbose here. And all I'm doing here is just selecting that I want the name property, and with a comma separation, I want the ID property as well. And again, as the sort of verbose command suggests, this is going to return a list with just the name and the ID columns instead of all the different properties that each process has. Now we can also append, for example, the first parameter as well, right? So I can say I just want to grab the first process in the list, right? Or maybe the first 5, right? I can also change this to last as well if I just want to get the bottom of that list. And so maybe not as useful in a process sense, but depending on what data and objects we're working with, it becomes very easy to start to cut these things up and only pull back what we need. Now, once we're dealing with objects, sorting them also becomes much easier, right? Because we can sort based off of an actual property. Right? And that means we can easily organize files by size, or services by startup type, or maybe users by username, right? Whatever we need, all of it can be done with the sort object commandlet, or the alias there is just the sort keyword. And so for starters, let's say that we want to look at the contents of a directory and sort the files based on their file size from largest to smallest. And so for example, I'll just target the system32 directory, again, just as an example here. And what I'm doing is piping the getChildItem output, again, just to list out all of the files from system32 into the sort object commandlet. And the property that I'm going to target here is the length, right? The length or the size of the files. And I'm going to sort that in descending mode here. All right, so if I were to kick this off, we obviously have a ton of different binaries in system32, right? So I'm going to Control-C to cancel that out. What I can do instead is also append, for instance, select object here, and say that I only want to pull the first, for example, 5, right? To grab the top 5 files based on their file size, right? And so what we're running here is basically listing out all of those items in the system32 folder and sorting them by their length, right, or their file size property in descending order, basically the largest files first. And then we're piping that over to select object to only grab the top 5 objects there. And so you can see already just how easy it is to start chaining different commandlets together in our pipeline to get exactly what we need. Now, there's still so many other commandlets that I find very useful here that we can cover, but just for the sake of time, I'll also include a cheat sheet with a ton of these useful formatting kind of commandlets. But lastly, I want to talk about in PowerShell, one of the greatest strengths is its ability to take the data that we gather and manipulate it and then save it out for later use or analysis. And so PowerShell gives us several commandlets that are designed specifically to export data into common file formats like CSV or JSON or XML, right? All widely used for reporting and automation and integration with other tools and scripts. Right, for example, if we want to export a list of running processes with specific properties into a CSV file, Well, we can use the adequately named export CSV commandlet. And this commandlet takes structured object data and writes it out as comma-separated values, which can easily be opened in Excel or maybe Timeline Explorer or processed by other scripts. Right, remember, everything in PowerShell is typically outputted as an object with properties, and so this makes it extremely easy for it to be able to be converted into structured data types like CSV or XML or JSON. Right, and so for example, what I can do here is call getProcess and pipe that over to select object. And this is where I can specify what columns or fields, but specifically what columns I want in my CSV file, right? So in this case, the name of the process ID, and the path to the underlying binary that's being executed. And then I'm just piping that over to export CSV here, basically to specify my path, in this case, just saving it in downloads called processes.csv. And then I'm adding the no type information parameter here. That's just to clean up our results and not to have any additional lines that we need to later clean up. Because if I run that, again, that was very quick, right? We're not getting any output in our console or our PowerShell session anymore. It's all sort of being saved over to that CSV file, right? And so if I were to grab the path here, I can just type out to basically print out the value of this file. And now we're going to see everything that we've listed here, all these different processes in a nice sort of CSV or comma-separated format. And so you can just see how quick and how powerful PowerShell can be when it comes to exporting and structuring our data. And for our last section here, sadly being short on time, we'll definitely have to do a part 2. But we can move on to the idea of variables, which you're more than likely familiar with as they're a general programming concept. But specifically, we can understand the ways in which PowerShell stores and passes in data during its operations. And most of this is going to be pretty standard, right? In PowerShell, we can define a variable just by prefixing its name with a $, right? So for example, I can set the name variable here to equal the string of Bob, right? And once a variable's been set, we can simply reference it later just by calling its name, right? So if I call the name variable, it's just going to print out the value, right? In this case, the string of Bob. And so this is going to assign that variable to the duration of our current PowerShell session. And so it exists only kind of in memory while that session is running. If we were to close out the PowerShell window, this sort of Bob variable is going to disappear. Now, there's some built-in kind of system variables that are generally available automatically as part of every PowerShell session. And so this includes things like $PS version table, right? And this is going to give us details about our current PowerShell version and the platform we're running on, right? I can call $home here, which is going to give me the path to the current user's home directory. I can call $PID here, basically to print out the current process ID of my PowerShell session, right? We also have things like null or things, again, like the $_ or the current object in a pipeline, right? Commonly used inside of the for each object and when we're running similar loops. Right, and these automatic variables are helpful for both interactive use and also for scripting, right? And some of these are more dynamic than others, right? And some of these variables can change during our session, right? Like the $_, while some others are more consistent, right? Like the $home variable is going to point to, again, my home directory here. And so as an example of how variables work in action, let's say we want to get the Windows product name from the registry and store that in a variable. And so what I can do here is run the getItemProperty commandlet, basically to point to the registry provider. And so this isn't something we got to cover, but basically we can query the registry and different areas of the operating system directly in our PowerShell session without any additional tools or functionality, just by using these different provider paths here. And so a ton of power and functionality here. But all I'm really doing here is just pointing to that registry key that contains the current version information about the operating system, and specifically I'm grabbing the product name field. And I'm saving that out, as you can see, to the $product variable. And so to print out the value here, what I can do is just call product. Right? And what this is going to tell us is that the variable product now stores an object that represents the registry key that we queried, right? And so this object, as we can see, contains its own different properties, right? So we have, of course, things like the product name, and in this case, telling us that we're running Windows 10 Pro, but we can also see a number of other properties like the PowerShell path here, right? Which is telling us where in the registry we grab this information from, right? Also the parent path and the child name, and also things like the PS drive, right? So in this case, what providers and drives did we use to access this location? And so this is a really good example of how PowerShell variables aren't just for simple strings or integers, right? They can also hold their own full objects. And so if I just wanted to print out that product name string, well, I can just call the product variable, and with this dot notation here, just say I want to grab this specific property, right? So if I run that, now we're just printing out the Windows 10 Pro string that we're getting from the registry. Now, I'll have this link down below as well, but what I've done here for the SOC 201 class specifically is put together what was originally supposed to be a quick reference cheat sheet, but really ended up turning into quite a thorough culmination of our foray into PowerShell for instant response that takes place during the curriculum. And I know we didn't touch on, PowerShell for IR too heavily in this short video, more of a beginner introduction, right? But we can definitely build up that skill set in future videos, or I would encourage you to take the SOC 201 course when it's released to really get your hands dirty with incident response and threat hunting. But the idea here is that we have all of these core commandlets that really come up time and time again, and I think I've done a good job of culminating some of the most important ones, right? And we looked at some of these, but definitely take a look at what, the different things you can do with PowerShell, right? Read through the descriptions, look at the different aliases you can use as a shorthand sort of reference, right? But again, things like get item or get content, even things like enumerating processes or services, scheduled tasks, even event logs, right? Or things like network related information or SMB or getting file hashes, right? And then we get down into more of these structure, these sort of formatting and output commands, right? Some of these we looked at like select and sort object, but we can also group and measure, perform different aggregations. We can format our output into different types, right? Like a table view or a list view. And of course, we can export out our different objects or output into various file types, right? Like JSON or CSV. And as we scroll down here, we're going to get into some specific incident response or threat hunting oriented collection examples, right? And so we didn't really touch on get CIM instance quite yet and some of these other commands here, but I would encourage you to read through this to see sort of the full gamut of what's possible when it comes to collecting information and enumerating different pieces of the operating system using PowerShell, right? And also how we can do that remotely and at scale. And so maybe in a future lesson, we'll cover more of that thing. But again, if you are really interested in that topic, definitely check out the SOC 201 course. I'm not trying to make an advertisement out of it or anything. I think there's some good overlap there if you are interested in the topic. And I think this is a good enough spot to end on and wrap up, right? You've seen how to run basic commandlets, work with aliases. We looked into objects and formatting and using variables, even providers and flow control, right? And started thinking in terms of what PowerShell's actually doing under the hood. And really, this is just the beginning, right? But it's enough for you to get from zero to functional, right? PowerShell is a massive ecosystem. You can use it to automate your environment, investigate intrusions, and really interact with all different areas of the operating system, right? We can dig through event logs, you name it, right? The more you use it, the more it's going to click. And so if this video helped you, drop a comment and let me know what you'd like to see next. Like I said, I'd love to plan follow-ups that go deeper into scripting and remoting and threat hunting, even using PowerShell as a fully featured IR tool. And if you haven't yet, be sure to check out the TCM Academy, where we have some fantastic courses on both offensive and defensive security operations. So thank you for watching and take care.